actually going to go through this question in 3 different ways. The mark scheme does it algebraically. I'm going to do it with combined ratio. So we've got cats to dogs, and at the start of the week, the ratio was 3 to 5. Then 32 cats arrived with no dogs, and the ratio became 5 to 3. So this is before in blue and after in red. Now, there's something that we know is staying the same, and that's the number of dogs. So if I can make these two the same, then I know that I can, well, basically I can then look at how the number of parts for cats has changed. So I'm going to times the top one through by 3 to give 9 to 15, and the bottom one through by 5 to give 25 to 15. So yeah, these stay the same, which means the increase here by 16 parts is equal to the increase in the number of cats. So 16 parts is equal to 32. That means 1 part is equal to 2. And there are 15 parts of dogs here. We have to go with this one rather than the original ones because that's what we're talking about where we got the 16 parts equal to 32 from. So we just need to do 15 times 2 to see that there were 30, well, there are, still are 30 dogs on Jane's farm. This is a really good approach. Actually, I would say the best approach for when you're dealing with a changing ratio question, which this is one, but when only one thing is changing. Okay, you just kind of make the things that are not changing the same and go from there. A more general approach, this is really good. It's more complicated, but it's really good when both things are changing and my previous method doesn't work, is we can say that the number we know that the ratio originally was 3 to 5, so we can just say that it's 3n to 5n. And now this is actually the number of cats and the number of dogs. I just don't know what n is, but I'm going to actually find out the number that I have, because that's when I can start adding to my ratio. So you can't just add in general, but if you actually have the number of cats and you add 32 to it, then we're okay. So then the new ratio is going to be 3n plus 32 to 5n. And that is going to equal 5 to 3. So with this method, I've actually created a ratio equation. Now I'm going to give you an example of a different ratio equation. 1 to 2 equals 2 to 4. This is a little bit easier to understand. We can see I'm just timesing this by 2 and this by 2. And we can get the scale factor by doing 2 over 1. The ones on the left divided by each other, and that's going to equal 4 over 2. So I'm trying to show you how we can go from a ratio equation to a fractional equation. Actually, I could also do it the other way around. I could do 1 over 2 equals 2 over 4. Go the other way, I'm timesing by a half. And that's going to be a bit more useful here because I want the ends on the top of my top, to be honest. So 3n plus 32 over 5, the two left ones divided again, just like I did over here, is going to equal 5n over 3. So you can see this method is more complicated, but it is a very general method. Cross multiply, giving me 9n plus 96 is equal to 25n. Minus 9, so we're going to get 16n equals 96. Therefore, n is equal to 6. So at the start, there were 18 cats and there were 30 dogs. That's the one we're interested in. At the end, there would have been 50 cats and 30 dogs. And you can see the ratios all work out, 3 to 5 at the start and 5 to 3 at the end. So again, 30. One more method. I wouldn't have thought to do it like this, but I really like it actually. It avoids that complicated equation that we ended up having to deal with in the second method. Not as simple as the first method, I don't think though. So what we're going to do is we're going to say that there are n dogs this time, not 5n, but n dogs. And that means because the ratio is 3 to 5, then we're going to have 3/5 n cats at the start. And then, so that's at the start, 3n cats. Yeah, because how am I getting that? We can see that I'm dividing by 5 to kind of get 1 part, really, n over 5, and then I have to times that by 3 to get the number of cats, 3/5 n. I'm then going to add 32 to that to get the number of cats when these ones have arrived. And now we've got a new ratio, but remember there's still n dogs, but this time there's going to be 5/3 n cats. This only works again because n is staying the same, whereas that second approach, whilst more complicated, was more general. So I can create an equation just in terms of the number of cats. Okay, the fractions are actually a little bit more awkward, to be fair. I think I'm gonna, what should I do? I guess I might even do a little subtraction. So 5/3 minus 3/5. Let's leave that 32 alone for the minute. This is all n, but let's just avoid the n for the moment. Okay, common denominator times by 5, so 25/15 times by 3, 9/15 gives 16/15. So that means when I do my subtraction, I've got 16/15 times n is equal to 32. I can actually then divide through by 16, which makes this 2 and this 1. Okay, I've got 1/15. That's a reverse fractions of amounts sort of situation. We've got 16/15, work out 1/15 by dividing by 16. So now 1/15 of n is 2. N is going to be 2 times 15 again, giving us our answer of 30. So 3 different approaches. Yeah, quite like them all.